Hey everyone, and welcome. Today, we're going to peel back the curtain on machine learning. We're getting into the nitty-gritty of how computers actually learn to think, to make decisions, and yeah, even to predict what's coming next. You see this stuff in action every single day. Your phone unlocks with just a glance, your inbox magically knows what's junk before you do. I promise you, this isn't magic, it's machine learning, and it works in some really fascinating ways.
So what's powering all this cool tech? Well, behind all these smart features, it really boils down to two core approaches, two fundamental philosophies, if you will, that guide how a machine gets smart.
Okay, so the easiest way to wrap your head around this is to think of it like this. On one hand, you have learning with a teacher. We call that supervised learning. And on the other, you have learning like an explorer. That's what we know as unsupervised learning. Let's dig into what that really means.
First up, let's meet the teacher. Supervised learning. The whole thing, and I mean the entire concept, comes down to one simple but really powerful idea: labels.
Okay, so what does that actually mean? Well, supervised learning uses data that already has the correct answers attached. It's kind of like giving the machine a giant stack of flashcards. It gets the question and the answer. Its job is to study them, make a prediction, and then check its work against the correct answer. Over and over, it slowly learns the patterns.
For example, picture this. You feed an algorithm 1,000,000 photos. And here's the key part. Every single photo is already tagged or labeled. This one is an apple, that one is an orange. After seeing enough of these examples, the machine starts to figure out how to tell the difference all by itself.
Now, this teacher method is really good at solving two specific kinds of problems. First, you've got classification, which is basically just asking, is this A or B? It's about sorting things into categories. Then there's regression, which is all about predicting a number. How much or how many?
Think about your email's spam filter. That's a classic example of classification, right? The algorithm was trained on tons of emails that humans already marked as spam or not spam. So it learns what spam looks like and can make a pretty good guess on any new emails that come in.
And then you've got regression. For this, just think about forecasting. A company can feed an algorithm all of its past sales data, marketing spend, the time of year, all that stuff. The model then learns the relationships between all those numbers to predict a value, like what sales will look like next quarter.
So, that was the teacher, learning from a nice, neat answer key. Now let's switch gears and meet the explorer, unsupervised learning. And its goal isn't to be right. Its goal is discovery.
The biggest difference here, and this is really important, is that unsupervised learning works with unlabeled data. There is no answer key. The machine just gets a massive amount of information and is basically told, go find something interesting in there. It has to find structures and patterns all on its own.
Okay, let's jump back to that photo example. The Explorer gets the same exact 1,000,000 pictures of apples and oranges, but this time there are 0 labels, none. Its job isn't to name them apple or orange, but to look at everything and basically say, it looks like there are 2 different groups of things in here.
So our Explorer has a couple of main tools in its toolkit for this journey. First, there's clustering, which is all about finding and grouping similar things together. And second, there's association, which is about discovering hidden relationships between different things.
You see clustering a ton with customer segmentation. An algorithm can just sift through mountains of purchase data and automatically group customers into different types, like say weekend shoppers or bargain hunters, without ever being told what categories to look for in the first place.
Oh, and association? We have all seen this one when we're shopping online. When a website says, customers who bought this also bought, that is an association rule at work. The algorithm just explored the data and found a super strong link between those 2 products.
All right, so we've met the teacher and the explorer. Now let's put them head to head and see how they really stack up.
Okay, so let's break this down. When you look at their goals, the teacher is all about predicting outcomes we already know how to define. The explorer, though, it's just looking for any interesting hidden insights. The data they use is the real game changer, labeled versus unlabeled. Supervised is awesome for things like spam detection, but man, labeling all that data can take forever. Unsupervised is perfect for recommendations, but the results can be a little less precise because there's no human guide.
So the big question is, how do you choose? Well, it really just boils down to 3 questions. First, what kind of data do you have? Is it labeled or not? Second, what are you trying to do? Are you trying to predict something specific or just discover what's in there? And finally, what tools do you have to get the job done?
But let's be real.
In the real world, data is messy, right? It's almost never perfectly one thing or the other. So what happens when you're caught somewhere in the middle? Well, luckily, there's a hybrid approach.
And this happens all the time. Imagine you have a mountain of data, but you only have the time or the money to manually label a tiny little fraction of it. What do you do then?
And that, my friends, is where semi-supervised learning comes in. You can think of it like giving our explorer a small map and a compass before sending it off into the wild. The model uses that little bit of labeled data to get its bearings, and then it uses that knowledge to make sense of the huge, unlabeled world around it.
You see this in incredibly important fields, like medical imaging. A doctor can label just a few CT scans to show the machine this is what a tumor looks like. The semi-supervised model then takes that knowledge and can analyze thousands of other unlabeled scans, flagging things for doctors to review. It's a huge help.
So, at the end of the day, if there's one thing you remember from all this, it's this. The big difference is the data. Supervised learning, our teacher learns from a guide. Unsupervised learning, our explorer has to discover the structure all by itself.
And that leaves us with a final, pretty mind-blowing question. As these explorer algorithms get more and more powerful, sifting through data on a scale we can't even comprehend, what new, totally hidden patterns about our work, our health, and our world are they just on the verge of uncovering? Something to think about. Thanks for watching.